Hello students, let us start with the new concept, that is types of finite automata. Finite automata, the definition we already have seen in previous lecture. It consists of 5 tuples, is divided into two types: finite automata without output and finite automata with output. Now finite automata without output, this type is again divided into three types, like deterministic finite automata, non-deterministic finite automata, which is again called as NDFA or NFA, and non-deterministic finite automata with epsilon moves, which is called as epsilon NFA or epsilon NDFA. Next we have finite automata with output. There are two types: Moore machine and Mealy machine. Now the types which we are having in this part, they will not going to produce any output, but here this type of machine or model will going to produce some output. Now let us check what is this deterministic finite automata. The finite automata are called a deterministic finite automata if the machine is read on input string one symbol at a time. That means what? If there is some state, suppose q0 is a state, it will going to read only one input. For this specified input, it will going to transit from this state to new state. It will not going to transit for the same input to a new state. Are you getting this? So there will be only one transition for a specific input. This is not allowed in DFA. Next, deterministics refers to the uniqueness of the computation. In DFA, there is only one path for specific input from the current state to the new state or next state. DFA does not accept the null move, or you can say the epsilon values. That is, DFA cannot change the state without any input character. See here, this is an example of a DFA in which we have three states: Q0, Q1, Q2. Q0 is initial state, Q1 is final state, represented with double circle, and this is with an arrow, and Q2 is any intermediate state. There are inputs like A and B. So Q0 is initial, Q1 is final. All other states we can say they are intermediate. Input symbol state A and B. Now check the formal definition of DFA. DFA is a collection of 5 tuples, as we previously discussed for finite automata. Same like that, we have Q, finite set of states; sigma, finite set of input symbols; Q0 initial state; F final state; delta is transition function. Based on this function, there will be transition from one state to the other state. Transition function can be defined as delta Q cross sigma, giving us Q. This is same like your previous finite automata, where we got that is delta is Q cross sigma is giving us Q, meaning is that this is the current state on some input symbol will going to transit to the new state or next state. So this is what transition function. Next we are going to discuss graphical representation of DFA. DFA can be represented by diagrams called state diagrams, or you can say the transition diagrams, which we discussed previously. The state is represented by vertices. This is a digraph, we can say. Digraph means it consists of vertices which are connected through arrows, we can say. So here the states represent the vertices of the graph, and the arc labeled with an input character show the transition. That means these arcs or the connections between these vertices, we can say these are labeled with some sort of input, and they will show the transition from this state to this state. The final state is denoted by a double circle, as we previously checked. Now let us check acceptance of a language. A language acceptance is defined by if a string W is accepted by the machine M is if it is reaching the final state by taking the string W. That means we have to start from initial state and we have to reach to the final state. and through this reaching or by following this path from initial to the final state, whatever inputs we are getting in between, these inputs will going to form a string. That string is nothing but this W. Next, a DFA accepts a string W A1 A2 up to AN if there is a sequence of states Q0 to Qn in Q such that Q0 is the initial state or starting state, and delta, that is Qi comma Qi plus 1, is giving us Ai plus 1 for all 0 less than I less than n, and this Qn belongs to F. Now when we see not accepted if not reaching the final state, we can say if we are following the path but we are not reaching to the final state, then we can say that it is not acceptable over that finite automata, or you can say DFA. Now let us solve the problems. Now first problem, we are having DFA to accept A. That means they had given the string as A. Sigma, suppose we are having only one symbol, that is A. Now we have to draw the DFA which accepts only one string of length 1 over that DFA. Now the first step, we require number of states. So the general formula used to calculate number of states is the minimum length string plus 1. Now here if we check the minimum length of string, there is no minimum, there is no maximum, they just had given the string only. So we can say that length of the string, that is 1 plus 1, that is equal to 2. So we require 2 states. So I can have Q0 and Q1. So this will be my initial state, which can be represented with an arrow, and this will be the final state. Whatever string is given, specify the transition like this, that is E. If I draw this much DFA, Q0, Q1, taking the input A, so we can say that we are starting from initial state. The input symbol is A, it is reaching to the final state, so the string A is acceptable over this DFA. Now check for the next problem, DFA to accept 0 or more A's. Now here we can have any number of A's starting from 0. Now before solving this problem, first we'll go for this one, DFA for no string, that means zero length string which we have. For this we'll draw the DFA first. Now if 0 length string if we are having, the number of states we will get 0 plus 1, that is 1. So we will have only one state, that is Q0 suppose, which is the start state, and it will be the final state. And if there is something like this without any transition, we can say this is for no string, or you can say 0 length string. This is the DFA which accepts 0 length string. Or there is only one state which is the initial and which is the final, and it will not going to take any kind of input, any kind of transition will not be there. Now DFA to accept 0 or more A's. Now in this case, if you check, minimum length of string is 0, so we can have only one state, Q0 suppose. If we say it should accept this, or it will be for no string or 0 length string, we have to represent like this, Q0 which is the initial and it is the final state, and 0 or more number of A's. So if we provide like this, we can say that 0 A's are acceptable over it. Now if I write something like this, which is taking the input A, this type of transition can be said as it's a loop transition. So loop is coming back to the same state, so we can have one A, like this. We can have single A, double A, triple A, like this we can have. So we can say that this is the DFA which accepts 0 or more number of A's.